Let's learn how to find the marginal rate of substitution of a utility function. The question is, if the utility function of a consumer is u is equal to x raised power alpha times y raised power 1 minus alpha, x and y are the two goods consumed by the consumer and u denotes the utility derived from the consumption of these two goods, we have to find out the marginal rate of substitution. Okay, so what is MRS? MRS is actually equal to the ratio of the marginal utility of good x upon marginal utility of good y. Let's write it capital here. Okay, and MUX means it is simply the change in the utility function due to the change in the consumption of good x. That is the partial derivative of this function with respect to x. So given this utility function, taking derivative with respect to x means the exponent of x becomes coefficient. So we have here, if I write it here, so alpha becomes coefficient, then we have x and alpha is subtracted by 1 by power function rule. Y remains same as it is, as 1 minus alpha is the exponent. Okay, similarly marginal utility of good y, if I write it here, marginal utility of good y means the change in the utility due to the change in the consumption of good y. That is the partial derivative of this utility function with respect to y this time. Okay, this time the exponent of y is 1 minus alpha, it becomes coefficient 1 minus alpha, x remains same as alpha, and we have y raised power 1 minus alpha and its exponent is subtracted by 1 by power function rule. Okay, now let's find the ratio, that is MRS. MRS is simply MUX upon MUY. Okay, MUX we calculated it as alpha x raised power alpha minus 1 y raised power 1 minus alpha upon MUY is this very term, that is 1 minus alpha, then we have x raised power alpha y raised power 1 minus alpha minus 1. Okay, now let us further solve this. If we do one thing, and if I have the space here, if I transpose x raised power alpha minus 1 to denominator, so let's first write alpha, so alpha, then we have y raised power 1 minus alpha, transpose this y to numerator, it will get multiplied but its exponent will change, so sign of the exponent sign will change. So if it is plus 1 it becomes minus 1, it is minus alpha it becomes plus alpha, it is, if it is minus 1 it becomes okay minus it becomes plus 1, and by the same logic we have here 1 minus alpha, let me write it here, then we have x raised power alpha, transposing this term it will get multiplied but its exponent sign will change, so we have x raised power minus alpha plus 1. Okay, solving further, you can see if I write it here, I don't have the space, MRS will be equal to, so we have alpha here, bases are same, we can add up the exponents. First this gets cancelled, then we have here, we have in fact y raised power 1 minus alpha plus alpha. Okay, alpha gets cancelled, we are only left with y in the numerator, and by the same logic here what happens here, okay, we are left with this very term here, so we have x raised power alpha minus alpha plus 1, again alpha gets cancelled, we are only left with x and 1 minus alpha, so this will be y upon x, this will be the MRS of x and y.